Children, today we are going to start the topic statistics. And in this topic, the first chapter is graphical representation. Children, we will learn how to represent statistical data with the help of diagrams and graphs. Right? And there are many ways to represent statistical data. We can draw a bar graph, we can draw a pie graph, right? So in this year's syllabus, we are having three basic graphical representation that we are going to discuss. The first is histogram, then frequency polygon, and ogive or cumulative frequency curve. First graphical representation, first graph that we are going to study is histogram. Before drawing histogram, let's discuss a few points that we need to keep in mind while drawing the histogram. So histogram, the first point is convert the data in exclusive form if it is in inexclusive form. Now, what is exclusive and what is inexclusive? Exclusive means overlapping class interval. Overlapping class interval means, suppose the class interval is given as 0 to 10, 10 to 20. So this is an overlapping class interval. And suppose the class interval is given 0 to 9, then 10 to 19, and then 20 to 29. You can see here the upper limit of the first class interval and the second lower limit of second class interval is same. Whereas in this interval, the upper limit of the first class interval is not equals to the lower limit of the second class interval. So we will convert this in exclusive. These intervals are called in exclusive class interval. We will convert these in exclusive class interval into the exclusive class intervals. Right, children? This is what we are going to do first to draw a histogram. So when it is in exclusive class interval given or non-overlapping class interval given, we convert into exclusive or overlapping class interval. This is first point that we need to keep in mind before drawing the histogram. Now let's move to second point. Now when we have converted the data into the class interval or rather exclusive class interval, we will represent the data on the graph. And on the graph, we will draw x-axis, y-axis, and along x-axis by using a specific or certain scale, or when it is given, we will take that scale only. Suppose it is given, take 1 centimeter equals to 10 units or 2 centimeter equals to 10 units. Sometimes it is given in the question and sometimes it is not given. So when it is given, we must need to follow the instructions of the question, right? The instruction given in the scale. We're not going to apply it or take our own scale in that case. So along x-axis we will be representing, drawing the class interval, and along y-axis we will be drawing the frequencies, will be representing the frequencies, right? And then when we do that, when we have drawn the x-axis class interval, then y-axis frequencies, what we are going to do, we are going to represent those class interval with respect to frequencies. That means we will be start drawing the rectangles, right? We'll be drawing rectangles or constructing rectangles with class interval as bases and corresponding frequencies as heights, right? We will draw the base along with the x-axis and height along with y-axis. So frequencies will become the height of those rectangles and bases will become the be the class intervals, right, of the rectangle. Note down this information, please. Now children, we will be drawing the histogram for the continuous group data. Continuous group data means the class intervals are overlapping class interval or in exclusive form they are given. So here in this sum it is given that the class interval are 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60, right? And the frequency it is given that 12, 20, 26, 18, 10, 6. And what we have to do, we have to construct the histogram of this continuous grouped data, right? So in histogram, what we have to do, we have to convert the inexclusive form into exclusive form first. So it is already given in exclusive form or in overlapping form. Now what we'll do, we'll start drawing the histogram. So I've taken in x-axis along, I've taken the class intervals. You can see here 10, 20, 30. This is 1 centimeter or 2 centimeter. Here no scale is given. So I've like taken 1 centimeter up to 10 units. So you can see on the graph there is only 10 blocks I've taken as 10 units. And along y-axis I have taken the frequency. So let's write all. Now it's there. Along y-axis I have taken frequencies. I have represented frequencies. Now what we have to do, we have to make the rectangles taking the class interval as the basis and frequencies at the height. So you can see here for the class interval 0 to 10, the frequency is 12. Now 0 to 10 is this class interval and the frequency is 12. This is marked. So when we draw the line, the breadth of the rectangle like this up to 10, then we join and make a rectangle. So with this portion, this rectangle is representing this is statistical data that in the class interval 0 to 10, the frequency is 12. Similarly, we'll be constructing more rectangles, like in the class interval 10 to 20, the frequency is 12. Then the class interval 10 to 20, the frequency is 20, right? So the breadth is, or the base is 10 units, 10 to 20 is 10 units, and the height is 20 units, right? Because the frequency is 20. Similarly, in the class interval 20 to 30, the frequency is 26. So between 20 to 30, the frequency 26, we will take C 25 and one more 26. So this way we will be constructing the histogram. Note down the solution, children. Now let's discuss another sum, children. This sum is based on finding or drawing representing the histogram for the discontinuous group data. Now what is discontinuous group data? When the class interval is non-overlapping or given in inexclusive form, right? Now if you read the sum here, it is given that the class interval is 30 to 39, 40 to 49, 50 to 59. Then you can observe that the upper limit of the previous class is not equals to the lower limit of the next class. That means 39 in first class, upper limit is 39, second class lower limit is 40. That means they are not same, they are not equal. That means they are inexclusive, non-overlapping, right? So to make this non-overlapping class interval to overlapping class interval, what we'll do, we'll calculate adjustment factor. So children, how we calculate the adjustment factor? Let's see here. We will subtract and divide. We will subtract the lower limit of second class minus upper limit of first class, right? And whatever the result comes, we'll divide it by 2, right? So this way we can calculate the adjustment factor to why we are calculating adjustment factor? To make this non-overlapping class interval into overlapping class interval, right? So if we calculate, if we see that the lower limit of second class is suppose like 40 is given, and upper limit of first class is 39. So here every time it's the same class interval, so we'll be taking the same, only one adjustment factor it will be there. So it will be 40 minus 39 upon 2, right? Lower limit of second class minus upper limit of first class upon 2, that will be 0.5. Okay. Now let's see, when we have calculated the adjustment factor, let's see this table here. This table, in the first column, it is given that class interval in exclusive form, right? So this is a non-overlapping class intervals given that we have mentioned in the question. Now what we are doing, we are converting this in exclusive form into exclusive form, class interval exclusive form. So how we are going to do, we are subtracting this adjustment factor from the lower limit and adding this adjustment factor to the upper limit. So when we subtract 0.5 from 30, we'll get 29.5. And when we add 0.5 to 39, we'll get 39.5. Similarly, in every class interval, we are doing the same thing, subtracting the class interval to the lower limit, from the lower limit, and adding to the upper limit. When we do that, we will get the class interval in overlapping form or exclusive form. And the frequency is remains same, right? Now see, from here we have drawn the histogram. So the first class interval is the lower limit of the first class interval is given in 29.5. So if suppose it is given 129.5, it is given, then what we'll do, we will take the help of this kink. Okay, So what we assume that this kink or this constriction, whatever class intervals they are left we have assumed that they are in this constriction, right, or kink. So whenever remember children, whenever the first class interval or second class interval not same, then or the distance is not same, then we draw kink, right? So you can see here this is 29.5, difference is 29.5, 0 and 29.5, and here the difference is 10. So we will draw kink here. Whenever there is a difference, we will draw kink, right? Now let's start drawing the histogram. The first class interval 29.5, 39.5, that means x-axis is representing the class interval and y-axis is representing the frequency. This is x-axis, right? So along x-axis we have taken the class intervals, along y-axis we have taken the frequencies. So let's start representing. The first class interval is 29.5 to 39.5. For that the frequency is 24. You can see the height of this rectangle, first rectangle is 24 up to 24 units, right? Second rectangle base is 10 and height is 16, so it will go up to 16 units. Similarly, third rectangle height is 9, then 15 and then 20. So when we accurately, neatly draw the diagram in our graph notebooks, and then we can see that the histogram is drawn. So this way we can construct a histogram or draw a histogram for the discontinuous group data. Right children? Note down the solution please. Now children, we will be discussing about cumulative frequency curve or an ogive, right? So these are the few steps that we need to remember when we are drawing a cumulative frequency curve. The first step is, the first thing that we have to do is to construct the cumulative frequency table. That means in general the cumulative frequency in the question is not given. We have to construct the cumulative frequency table and find the cumulative frequency for every class interval, right? This means that. Let's move to second point. The second point, it is written that mark the actual class limit along x-axis. That means, excuse me, generally what we'll do, we suppose it is not given in non-overlapping class interval is given. It is not given in overlapping class interval. Then what is actual class limit? That means the class limit of the overlapping class interval is the actual class limit. That means we have to convert the inexclusive form, class interval in inexclusive form, to class interval in exclusive form, right children? And we have to plot that, mark the points along x-axis of the class interval. Let's see the third point. Mark the cumulative frequencies of respective classes along y-axis. That means we'll be plotting in histogram. We were plotting frequencies along y-axis. Now in frequency ogive or ogive, we'll be plotting frequency along y-axis, cumulative frequency along y-axis, right? Remember this, cumulative frequency will be plotted along y-axis. Then the fourth point is plot the points corresponding to the cumulative frequency at upper limit point. This means children that whatever cumulative frequency will be plotted, that will be plotted at the upper limit of the class interval. Okay. Whenever the cumulative, suppose the cumulative frequency of 0 to 10 is 9, then where 9 will be plotted? At 0, at 5 or at 10? So 10 is the upper limit. So the cumulative frequency of every class interval will be plotted at the upper limit, right? And then when all the points are plotted, then what we'll do? We'll join the points plotted by a freehand curve. This is all what we are going to do when we are drawing the cumulative frequency curve or ogive, right? Note down the steps please. Let's see another sum children. Now in this sum, we'll be discussing how to construct an cumulative frequency curve or an ogive, right? So here it is given that draw an ogive of the following distribution. And we are given with the class mark of the class interval. What is class mark children? The upper limit, the sum of upper limit plus lower limit by 2 is the class mark. And we are given with the class mark, and we have to find and we have to construct the cumulative frequency curve. So we are given with class mark as 12.5, 17.5, 22.5, 27.5, 32.5 and 37.5. And the frequency is 10, 15, 17, 12, 10, 8. Now remember children, when we are given with class mark, so how we are going to obtain the class interval from the class mark, right? Now you can observe, you can find the difference between two class mark. Now the difference between two class mark is 17.5 minus 12.5. So what we'll do, we'll take the difference of two class mark and divide it by 2, right? So you can see the 17.5 minus 12.5 will be, what we'll get, 5. 5 upon 2 will be 2.5, right? That means the second class mark minus first class mark upon 2 that we have to do. And that what we'll get here, 2.5. Whatever we get, what we'll do, we'll subtract and add to the class mark. So when we subtract this 2.5 in this class mark, we'll get the lower limit of the first class. When we add to this 2.5 to this 12.5, we'll get the upper limit of the first class. So similarly, we will calculate the class interval of every class. So when we subtract 2.5, we'll get 10 and add 15. When we subtract here, we'll get 15. When we add, we'll get 20. Similarly, 20, 25, 20, and we have obtained all the class interval from the given class mark. And the frequency that we are given with is 10, 15, 17, 12, 8, 10 and 8, right? And for constructing cumulative frequency curve, we need to construct the cumulative frequency table. That means now we have to find the cumulative frequency from the frequency given. So how we will be calculating cumulative frequency? By adding the frequencies. Suppose the cumulative frequency of first class will same as the frequency of first class. It will remain same, 10, 10. Now 10, this added with 15, what will it become? 25. This 25 will get added to 17, it will become 42. This 42 will get added to 12, it will become 54. 54 plus 10, it will be 64. 64 plus 8, it will be 72. So this is the cumulative frequency table for the given frequency table, right? All the cumulative frequency for the class interval we have calculated. Now what we have to do, we have to construct the graphical representation of the ogive. So what we have done here, I have taken the class interval along x-axis. You can see 5, 10, 15, 20, 25, 30, 35 and 40. And the cumulative frequencies along y-axis, right? 5, 10, 20, 30, 40 up to 70, because maximum cumulative frequency we have 72. So keep in mind, when you draw the cumulative frequency along y-axis, that maximum frequency what you have to plot. Now let's start plotting. What we have discussed in the points, that the cumulative frequency will always be plotted at the upper limit of the class. That means the cumulative frequency of the first class is 10. This 10 will be plotted at the upper limit, which is 15. So when you plot 10 at 15, we will get this point. Then this 25 will be plotted at 20. At 25 we'll get 20. Then this 42 will be plotted at 25. This 42 will be plotted at 25. Similarly, all the points we'll get. And then what we'll get, what is left? We have to join all these 3 points with freehand. So when we join this 3 point with freehand and this point to the lower limit of the first class interval, that means 10, right? So this is the ogive that we will get for this sum, right? Understood, children? Note down the solution, please. Do the graph, always do the graph neatly.